What if a battery material was built from a vitamin and knew how to destroy itself once we're done with it? Yep, the same vitamin B2 you've seen on cereal boxes. Here's the problem in one breath. Batteries work, recycling doesn't. A lot of the plasticky parts in batteries are hard to take apart. Some chemistries get sketchy at end of life. We want power now and a clean exit later. A new 2025 study, published 4 months ago, tried exactly that. The study titled, "A Bioinspired and Degradable Riboflavin-Containing Polypeptides as a Sustainable Material for Energy Storage." The idea: use vitamin B2 to store charge and hang those vitamin beads on a polypeptide backbone, which is basically a chain of amino acids, the same building blocks as protein. These amino acids are parts our bodies and nature already understand. Think beads on a string. The string equals the amino acid chain. The beads equals vitamin B2 units that can accept and give back electrons. When you see redox in the paper, it just means that take and return of electrons. So what did they actually do? They made that amino acid chain so it can later break down, degrade, into simple pieces. Snapped vitamin B2 beads onto it. Check that it really stores charge, clean signal near a standard point on the voltage scale. Tested how it comes apart with enzymes, nature's scissors, and ran a basic cell safety check to see if it's gentler than older, harsher materials. So what exactly did they discover? They were able to see that the polymer did indeed store charge with repeatable signal where the vitamin units load and unload electrons. They also saw that the battery could come apart. Under mild acid, the chain breaks back into recognizable pieces, amino acid bits, plus some vitamin fragments, friendlier to cells than their previous petrochemical version, which is a big win for safety. But what's cool is that the energy per gram is lower than their older non-vitamin material, and they haven't even built a full battery with it yet. So why exactly should you care? If the battery polymers start life as amino acids and vitamins and end life as simple known molecules, recycling gets closer to a recipe rather than a rescue mission. However, it's not perfect. Enzymes were a bit slow, and those vitamin beads are bulky and get in the way. Now here's my opinion. I think the team did a great job. I would recommend them to add a small spacer between the bead and the string to pack more vitamin units, more energy, while leaving room for enzymes to chew the chain later. Now the meme of the week. Your turn. If you had to pick one first, more energy now or cleaner end of life, what's your move? See you next week.